core of my talk was about probability, so let me get there now. So why is it so important to add probabilistic inferences? I guess most of you guys already understand why it is important, but just for completeness, yeah, usually the output of data science goes into reports and publications, but there's actually not a formal trace where the data came from. By formal, I mean a computerized version, or a version that is on the computer that you can share with other people, and they can actually use your data again to redo it or extend on it. There's also no formal link to the actual methods you used, whether it was Spark ML or an R script or whatever, or who did it or when you did it, and not even why you did it. Yeah, and you can't compare it to an earlier result. So you do the same method again a year later. It's very hard to compare it with the computer. I mean, you could look at the publications and try to visually look at the differences, but you can't use your computer to define the difference in the results. And also important is you might do, and I'm going to show you this in the examples, but if you do some, say, a cluster analytics, yeah, then if you don't put it back in your database, then you can't use that as the next step for a follow-up analytics. Yeah, so basically what you want to do, you want to use the output of data science as building blocks so you can do more data science on top. Yeah. And then another point is, that it's just a general point, is that the output of your data science is just not queryable. That is a correct English word. Yeah. And this has all kinds of disadvantages. Yeah, you can't reproduce your research findings. There's problems with security and compliance, and most importantly, there's a lot of duplication of efforts. So anyway, that's the importance of putting the inferences back in your database. So let me give you the first demo. And so I have on my laptop a VM here with part of my healthcare data running. Let me start Gruff. Clean the screen. So this is Gruff, our tool on top of AllegroGraph. And what I'm going to show you, well, first I want to give you a little explanation. So a friend of mine has a 4-year-old, and about, I would say, 3/4 of a year ago now, he gave his kid a spoonful of peanut butter, and the kid instantly went into an anaphylactic shock, had to go to the hospital 30 minutes later, and they barely saved his life. And then the doctor looked at his medical charts and said, you know, I could have predicted this because peanut allergy goes always together with, well, this kid has dermatitis and it has asthma, and it always goes together with peanut allergy. Yeah. So my friend came to me and said, Jans, you got all this data. Can you actually see if this is really true? So what I did, he said, okay, let me try. And I took all the data from that we have about diagnostics, and I computed the co-occurrence between each diagnostic. So how many times in my database does someone have a broken leg with a blind left eye, yeah? And how many times do you have dermatitis and asthma? Yeah? So you get a number for each. And then you look at the distribution of each of the diagnostics, and you look at the co-occurrence, and you say, so how strong is this co-occurrence? Is this something that is just that I could expect by chance, or is this a really strong? And the name of this measure is the odds ratio. You see here, yeah. And for those that are familiar with data science, this is the Wikipedia description. You can look that up yourself. Yeah, and here is the basic table where you compute. You might have the peanut allergy, the number where you both have peanut allergy and ingestion to dermatitis, or where you do have peanut allergy but not dermatitis, or you don't have peanut allergy but you do. Anyway, you get my point, and then you compute this thing called the odds ratio. So once you have these odds ratios, I turn those back into triples and back into distributed AllegroGraph. Yeah, and here is when I did this for the first time. So basically I created this query, odds ratio for peanut allergy. Yeah. So this is a visual query. Yeah, it says if given that I have allergy to peanuts, yeah, give me all the odds ratio objects that point to another ICD-9 code. Yeah, and when I run the query, I mean, I was blown away when I did the query for the first time, because this was exactly what the doctor said. Yeah, if you have peanut allergy, then the odds ratio for dermatitis is 2 in the 10. Yeah, that means the co-occurrence is incredibly large. And then asthma was high. Another type of asthma was high. Then we have another type of dermatitis, and finally acute upper respiratory infections. Yeah, so this was just exactly what the doctor said. I can turn this into a visual graph. Yeah. Yeah, so you probably realize that this is the same picture that you just saw. I like to show it this way. And then the next thing I wanted to do, or what my friend wanted, is he wanted to know if these symptoms related to allergy to peanuts are related themselves through odds ratios. So, well, I said I can easily do that. I can highlight these new symptoms. I choose the predicates from 2 and from 5 and to 5, yeah, and I hit the button Shift F here, and I basically compute the shortest path through odds ratios between all of them. And what we saw, yeah, is we get new symptoms, only 5, yeah, and they're still related. It's allergy again, it's viral pneumonia, close to asthma, allergy to milk products, eczema, which is another type of dermatitis, and then the common cold. And if I will do it one more time, and I will do this, oh, 1 second, then I could get only 2 more factors. I will get wheezing and asthma. Wheezing is obviously related to asthma, and asthma is related to asthma. Yeah. So now I have like a perfect cluster around the concept of allergy to peanuts. Yeah, and I can do this for anything. So one thing I like to do for audiences is, when I do this, I take, say, lack of housing. So this is a visual query that says, okay, oh, so by the way, this is something we run in the Bronx, and there's quite some people without housing, yeah, and so lack of housing is an ICD-9 term. It's a context term that specifies that, for example, you're homeless and you need antibiotics, then instead of pills you get a shot, yeah, and so for the billing you have to use this code. Anyway, the thing is now, lack of housing, yeah, given that I have lack of housing, what is the most related thing to lack of housing, yeah, and then how are this concept, can I find a link to itself again, yeah, so is it related to other concepts that all are related to the concept related to lack of housing? So I can run this query, and I get a graph that I see here, and so you probably are still guessing what is the most common thing. Then what you find that it's actually all related to cocaine abuse, cocaine dependence continuous, and alcohol. Yeah. So I can take any concept, any disease that happens in my 2.7 million patients, link it, and then say, so how is it related to every other disease that I see in my patient data? So let me go back, yeah, because another thing I wanted to show you is that, so this was the allergy to peanuts and how it related to all these diseases. But each of these terms is, so these blue things are ICD-9 terms, but they're related to the knowledge base. So how are they related to the knowledge base? Let me show you. So each of these terms has a exact match. And let me take this one. And this thing, so this is the exact match, that is the mapping object between billing codes in the knowledge base. And then I can look at the child. But this concept is a child of some other concept. So now we're going into a SCOS hierarchy. This thing is then again a child of something else, dermatitis and eczema. And I could go all the way up, yeah, to whatever I'm interested in. I can do this also, I could also do this a little bit more automatic. I could say, well, let me find the links in the knowledge base between, say, eczema and this particular dermatitis here, yeah, and it finds automatically a link. Or I could say, how is this asthma related to this eczema? And this one has to search then, because this is a much longer search, because it goes through, in this case, about 350 million triples. And it finds that it ultimately all linked to hypersensitivity. Let me show you a little bit better here. Yeah, so we have here the astringent asthma. We have here dermatitis, and it ultimately all links together through this concept of hypersensitivity. Anyway, so this is a basic demonstration of how you add probabilistic inferences back into the database, and now you can link it with whatever you want. Yeah, so let me go back to the presentation. Actually, now let me give you another example. Say, another example of how you actually can do queries, because what I showed you so far was discovery in graph. But how can you do a query where you mix the knowledge base and the probabilistic data? So I could do this, yeah, and this is a query, and let me just do this in English. Yeah, you say, find in the knowledge base everything related to diabetes. Just find all the ICD-9 terms that are related to diabetes. Then also find all the ICD-9 terms that are ultimately related to something with vision, eye, or retina. Yeah, and then between these two sets, find the odds ratios between things related to diabetes and things related to vision. Yeah, and so I do this query, and this is a huge search. Normally, but not in the demo, I actually use the child relationships here, and I use the path expressions, so you get even more results. Anyway, it doesn't matter in this case. And then I get a visual graph of, and this is for researchers that kind of want to explore how do these two domains actually link in my patient set. Yeah, and now you can see that this diabetes, this type of diabetes, it's called, anyway, you can read it on the screen. Yeah, it's related to unqualified visual loss of an eye and unspecified retinal detachment, retinal hemorrhage, and some other thing here. Then you go through a lot of terms in the knowledge base in the taxonomy system, and ultimately you get back to other probabilistic relationships with polyneuropathy, diabetes, another type of diabetes, etc. Yeah. Now, there's no way we can talk about what this actually means today, but you get my point where we do a query you could never do before, and that is link a knowledge base to actually empirical data. All right.